Today, I'll be giving you a crash course on superposition. Superposition is a circuit analysis technique used to find the currents and voltages in a multi-source circuit. These sources can be either current or voltage sources. The greatest advantage of superposition is that it allows larger, more complex circuits to be solved with minimal time and effort. However, this method does not come without its limitations. It can only be applied to circuits in which the elements have a linear relationship between the voltage and current. Now let's get into the method. Firstly, identify all the variables and list the variables you are trying to find. Next, select the source and remove all remaining sources by replacing any voltage source with a short circuit and replacing any current sources with an open circuit. Now, we are left with a simple circuit which can be solved using Ohm's law or any other appropriate methods. Finally, you want to repeat these steps for all other sources in the circuit. Now simply sum the results from each source, making sure to keep in mind the direction in which the current flows in each simplified circuit. Now let me run you through an example. Here we have a circuit with two voltage sources. I have labeled each element and listed what I am trying to find. In this case, I will find the voltage and current flowing through each resistor. So next, I replaced one of the voltage sources with a short circuit, leaving me with a simple single source circuit. I then found the total resistance, used the voltage divider rule to find the voltage across the resistors, and then used Ohm's law and Kirchhoff's current law to find the remaining current through resistors 1 and 2. Now I repeated these steps, once again transforming the voltage source with a short circuit and solving for the unknown values. This circuit happened to be symmetrical and the working was identical. I would like to note that between the two simplified circuits, my current has changed directions. Therefore, the I1 and I3 values will have negatives. These negative values are shown here in the table. In this step, I've placed the data in a table and summed the results to find the total values for each resistor.
Okay, so now I've set the circuit up. Here is the breadboard, the two 220 ohm resistors, the 100 ohm resistor, the two 9-volt batteries, and wires linking it all together. I will use this digital multimeter to measure the voltage across the 100 ohm resistor and verify if our method is correct. As you guys can see, I've measured 3.78 volts across the 100 ohm resistor. Although that is about half a volt away from our calculated values, we must also consider the uncertainties in the resistor and resistance in the wires. Once again, I am a trained professional and do not try this at home. Thank you guys for watching, and I'll see you next time.